So welcome back to No Math Sum. This time around we are going to learn how to solve simultaneous equations using what we call the matrix method. So before we start up, we're going to first get the matrix of this number here, which is 2, 1, then here 3 and 4. Yes. So if you call this matrix A, yes, and then here I have this matrix this side 6 and 8, and we call this matrix B. So in simple terms, we are going to have a matrix 2, 3, 1 and 4. Then if multiply it by xy, you are going to get 6, 8. Yes, but you know that if I multiply this A by the matrix xy and I get the matrix matrix B, this is a 2 by 2 matrix and this is a 1 by 2 matrix. So if I multiply these matrices and I get B, I can also multiply this side by the inverse matrix of A times the inverse matrix of A. Reason being, if I multiply any matrix by its inverse, I get what we call the identity matrix. Yes. And if I multiply any identity matrix times that same matrix, I get the same matrix. This is B and A. The inverse of A. So what I'm going to do in this case, I'm going to just multiply the B and I multiply by the inverse of A. So I look for the inverse of A. Yes. So what is the inverse of A? For the inverse of A, it's similar saying 1 out of the determinant times the adjoint. Yes. So I'm going to get the determinant of that matrix. What's the determinant? The determinant is the determinant of this matrix 2, 1, 2, 3, 1 and 4. Determinant is 2 times multiply this 2 times 4, which is 8, minus 1 times 3, which is 3. Determinant is 5. Yes. Then also get the adjoint. So for the adjoint, the numbers in the major diagonal, this diagonal here, you exchange them 4 and 2. Then the numbers in the minor diagonal here, you change their signs. If it is a positive, it becomes a negative. This is also a positive, it becomes a negative. So this is their adjoint. So this is their adjoint. Yes, we are still together. And then you're going to have my xy equals to this matrix here, 1 out of 5 times the determinant. So my inverse matrix is going to become 1 out of the determinant, which is 1 out of 5. So if I put the 5 inside, it's going to become 4 out of 5. Then here, negative 1 out of 5, negative 3 out of 5, and the 2 out of 5. Yes. So I'm going to multiply this matrix here, this matrix here by this matrix here, so that we get this formula here. So I have 4 out of 5, negative 1 out of 5, negative 3 out of 5, 2 out of 5. I'm going to multiply it by 6, 8. Yes. So here I'm going to multiply 4 out of 5 times 6, which is what? This is 24 out of 5. Yes, plus negative 3 times 8, it is negative 24 out of 5. It's my value for x. Then my value for y This is going to become 24 minus 24, which is 0 out of any number which is always a 0. So for this part, I'm going to have negative 1 times 6, I get negative 6 out of 5. Then plus 2 times 8, I get 16 out of 5. So negative 16 plus 16, here I get 10 out of 5, which equals to 2. As simple as that. I just get the inverse of this matrix and I multiply it by this part here, because I've seen that if I multiply these two, the second equation times the inverse, I'll get what we call the value of x and the value of y. So this is how you can use the matrix method. Let us go to the second number. Let's find the solution. So I'm going to find the inverse matrix of this equation here, of this matrix here, which is 1 out of the determinant times the adjoint, yes, of which you first look at the determinant of the matrix 3, 1, 3, negative 4. So this part here, the x is negative 1 and the y is 2. So if you have to get the determinant, you see that the determinant is the same as 3 times 2, which is 6, minus negative 1 times negative is a positive, it's positive form. My determinant is 2. Yes, and the inverse, for the inverse, as I told you, because this is our equation, our matrix, sorry, this is my matrix. So for me to get the inverse, the numbers in the major diagonal 3 and 2, they interchange and becomes 2 and 3. Then these other numbers, you just change their signs. If it's a negative, it becomes a positive. Positive 1 and positive 4. So I'm going to get the 1 out of adjoint and I multiply it. So my value of x and y, multiply it by A inverse times the B. Yes, of which my A inverse for this case, it is here, and my B, it is 10 and 2. So my A inverse, this is multiply this by 1 out of 2. Yes, because 1 out of determinant times adjoint. So my A inverse for this case, that is this equation here. If we wait, I have this side and I multiply 2, 4, 1, 3 times 10 and 2. Yes, I can first write the half here and I get the value of x and y, which is 2 times 10. Here I'll get 20 plus 4 times 2, I get 8. Yes, 1 times 10, I get 10 plus 3 times 2, I get 6. Yes, I paste it together in this. So here I have my half this side. 20 plus 8, I get 28, and here I get 16. If I multiply by half by 28, here I get 14 as my x, then here I get 8 as my y, if I include this a half inside. So my final answer for x equals to 14, and my answer for y equals to 8. Yes, so you're using the matrix method to solve these simultaneous equations. So if we look at the third solution, this part here, you first write the matrix, which is 1, 1, 1, 3, 1. This is my matrix A. Then my matrix B, it is 2 and 5. Yes, but you know that my x, to get x and y, you multiply the inverse times B. So the inverse of this matrix, the inverse, we're going to first get the determinant, which is 1 minus 3, which is negative 2. Yes, which is negative 2 for that case. So Then I also get the adjoint for this case. The numbers in the major diagonal just interchange. Since it is 1 and 1, it remains 1 and 1. Then for these other numbers, we just change their signs. Yes. So my A inverse becomes 1 out of 2, but this 2 is negative, so it changes this 1 out of 2, so into the adjoint, which is 1, -1, -3, and 1. Yes, hope you're still together. So I'm going to multiply this by the B. So -1 out of 2. Here I have 1, -3, -1, 1. Multiply it by the B, which is 2 and 5. Yes. If I multiply this to here, I'll get 1 times this negative half remains outside still. 1 times 2, I get 2, plus -1 times 5, which is -5. Then -3 times 2, -6, plus 1 times 5, which is plus 5. So for this part, I'm going to remain with -1/2 outside. Yes, -1/2 outside. 2 minus 5, I get -3. Minus 6 plus 5, I get -1. So if I multiply this by 1/2, I'm going to get my value of x as 3 out of 2, and my value of y as 1 out of 2. Yes, so this matrix method for it is very easy. Just by the inverse of the matrix times that B, and you get your answers. Simple. So if you like the videos, please you can leave a like button so that the video can move around to people who need it and where the video will be of great help. Thank you very much. This is No Math Sam. Please subscribe and continue liking and subscribing to the channel so that we get more views. I want to reach the goals to reach 1,000 views by the end of this month. Please, thank you for your support. Thank you very much.